Introduction to the OpenAI API in Python. Welcome to your hands-on beginner lesson. We will explore the OpenAI Python API together. You will learn how to use the API for tasks like chat, speech-to-text, and more. Let us get started. Running the cell now. What is the OpenAI API? The OpenAI API lets you use advanced AI models in your own programs. You can generate text, transcribe speech, or create embeddings. Many popular apps use this API to add smart features. You do not need deep AI knowledge to begin. Running the cell now. Why learn the OpenAI API? AI can save time and open creative possibilities. Automate tasks like summarizing text or converting speech to text. Improve user experiences in apps with natural conversations. The skills you learn here will help in many fields. Running the cell now. Getting set up. You need a Python environment and an OpenAI API key. This lesson runs in Jupyter, which is great for experiments. The API key is already in the environment for you as OpenAI_API_key. Running the cell now. Let us import the warnings module and filter them out. Import numpy as np. We set the random seed to 42 for reproducibility. This means warning messages will not clutter our output. Running the cell now. This code sets up the environment by suppressing warnings and ensuring reproducible random results with a fixed seed. Although there is no visible output, these steps are essential for clean and consistent experimentation as you begin working in Jupyter with the OpenAI API. Notice how this prepares your notebook for smooth and predictable code execution throughout the lesson. First, import the OS module and the OpenAI client library. The OS module lets us access environment variables, and OpenAI is for talking to the API. Running the cell now. This code sets up the environment by importing essential libraries, OS for system tasks and OpenAI to interact with the OpenAI API. Although there's no visible output, this step is crucial as it prepares your Python environment to make API calls later in the lesson. Getting these imports right ensures smooth execution in your Jupyter notebook. Get your API key from the environment variables. This keeps it safe and not visible in the source code. Running the cell now. Here, the code retrieves your OpenAI API key securely from the environment variable, which is essential for authenticating API requests without exposing sensitive information. There's no visible output because this step is about setup and ensuring the key is ready for use in later calls. This prepares your Python environment to interact safely with the OpenAI API during the lesson. Now create a client object for OpenAI. The client will let us make requests easily with our API key. Running the cell now. This code initializes the OpenAI client using your API key, but it doesn't produce any visible output. Notice that this setup step is essential for authenticating your requests in later lessons, ensuring you can access the API smoothly within your Jupyter environment. Key concepts. Models are different AI brains for different jobs. Prompts are messages you send that the AI responds to. Always handle API keys with care. Cost depends on the model and usage. Never share your key publicly. Running the cell now. Let us try a basic chat completion. We call the client's chat completions create method to generate a response. We specify the model to use, which is GPT-4.1 mini. We pass a list of messages, here, a single user message saying hello. We complete the request and store the response. Finally, we print the content of the first choice from the response. Running the cell now. This output shows the AI model GPT-4.1 mini responding to a simple hello prompt with a friendly, helpful message. Notice how the code sends a prompt as a message and prints the model's reply, demonstrating the basics of chat completion. This illustrates how different models respond differently to prompts, key to choosing the right AI brain for your task. How chat completions work. Each message has a role like user or assistant. The model reads your messages and replies in context. You can choose a faster, cheaper model or a stronger model depending on your needs. You can create smart chatbots or assistants. Running the cell now. This line is a comment explaining that the user's input will be used as the chat prompt. This line gets the user's message by prompting them to type their input. This line calls the function to create a chat completion using the API client. This line specifies the model to be used for generating the chat completion. This line passes the user message inside a list, setting it as the content of the user role for the chat. This line closes the function call that creates the chat completion. This line prints the content of the first choice returned from the assistant's response. Running the cell now. This output shows the assistant's reply generated in response to your typed message, demonstrating how the model reads your input and produces a relevant, coherent answer. Notice how the completion directly addresses the user's query with clear, informative content, illustrating the core concept of interactive chat completions in action. Speech-to-text with Whisper. You can turn spoken words into written text using OpenAI Whisper. This is called speech recognition. It is great for notes, captions, and accessibility. Running the cell now. Prepare to use speech recognition by setting up the environment. Open an audio file named sample.wav in binary mode. Change the file name if needed. Call the transcription method on the client to start transcribing the audio. Specify the model to use and provide the audio file as input. Print the transcribed text that the model returns to the console. Running the cell now. This output shows a file not found error because the code couldn't find sample.wav in the current directory. This highlights the importance of ensuring your audio file path is correct before running speech recognition with Whisper. Fixing this allows the model to access your audio and convert speech to text as intended. Prompt the user to try transcribing a different audio file by using input. Ask the user to enter the file path of their audio file. Open the specified audio file in binary read mode. Begin creating a transcription request using the client API. Specify the speech-to-text model to use, named a Whisper 1. Pass the opened audio file as the input to the transcription request. Close the method call for creating the transcription. Print the transcribed text result from the API response. Running the cell now. The output shows a file not found error, indicating that the specified audio file sample.wav could not be found at the given path. This error highlights the importance of providing the correct file path when using Whisper for speech transcription. Ensuring the file exists and the path is accurate allows the model to process the audio and convert speech to text successfully. Embeddings, making text searchable. Embeddings turn text into lists of numbers called vectors. You can use these vectors to compare meaning, power search, or cluster ideas. Embeddings help AI organize language by meaning rather than spelling. Running the cell now. Create an embedding for a given sentence using the client. Call the client's embeddings creation method. Specify the model to use for creating the embedding. Provide the sentence we want to convert into an embedding. Close the method call. Print the length of the embedding vector returned. Running the cell now. This output shows the size of the embedding vector created for the sentence "Machine learning is fun." Notice it's 1536 numbers long, meaning the text is translated into a detailed numerical representation. This vector size defines the dimensional space used to capture the sentence's meaning for tasks like searching or clustering. Explain that we will compare two sentences using their embeddings. Import NumPy so we can do math with arrays of numbers. Create two example sentences that are related in meaning. Call the client's embedding API to generate embeddings for the sentences. Specify which embedding model to use in the API call. Pass the list of sentences as input to get their embeddings. Extract the embeddings for each sentence and convert them to NumPy arrays. Say we will use cosine similarity to compare the two embeddings. Calculate the cosine similarity between the two embedding vectors. Output the similarity score so we can see how alike the sentences are. Running the cell now. This output shows the cosine similarity score of about 0.81 between the embeddings of two related sentences. Notice the high similarity value close to 1, indicating the model captures their shared meaning despite different wording. This demonstrates how embeddings represent text by meaning, enabling powerful comparison beyond exact text matching. Error handling. Always use try-except blocks when calling the API. This helps prevent crashes if there is a network error or a typo. Good error handling is important for real-world apps. Running the cell now. This line is a comment explaining the purpose of the code block. Start a try block to catch any errors during execution. Attempt to create a chat completion response from the client. Specify the model to use for generating the response. Provide the message content for the chat request as a list of dictionaries. Close the create function call. Print the content of the first message choice from the response. Start the except block to handle any exceptions thrown in the try block. If an error occurs, print the error message to the console. Running the cell now. The output shows a successful API response returning a joke, demonstrating that the try-except block allowed the code to run without crashing. This highlights the importance of error handling. If the API call had failed, the except block would catch the error and prevent the program from stopping abruptly. Notice how the intent is to safely manage potential issues while still getting a valid result when possible. Best practices. Use the smallest model that does the job to save money. Limit how often you make API calls. Never share API keys or put them on GitHub. Check model and API documentation for updates. Running the cell now. This is a mini project to convert audio into text and then summarize it using a chat model. We open the audio file named sample.wav in binary read mode. We start creating a transcription request with the client for audio processing. Specify the transcription model Whisper1 to be used for converting audio to text. Pass the opened audio file as the input for the transcription. We then create a chat completion request using the client for summarization. Specify the chat model GPT for 4.1 mini to generate the summary. Prepare the messages sent to the chat model, including the system prompt and user input. Set the system message telling the model its role is to summarize transcripts. Set the user message content as the transcribed text to be summarized. Print out the summary text that the chat model has generated. Running the cell now. This error tells us that the audio file sample.wav is missing, so the transcription step can't run. It highlights the importance of verifying file paths before making API calls, which aligns with best practices to avoid wasting resources and ensure smooth processing. Always check that input files are accessible to prevent unnecessary API usage and errors. Troubleshooting tips. If you see API key error, check your environment variable. For connection errors, check your internet. If you get usage or rate limit errors, try again later or use a smaller model. Read error messages carefully, they will tell you what to fix. Running the cell now. Introduce the challenge to summarize your own audio file. Prompt the user to enter the path to their audio file. Open the specified audio file in binary read mode. Start the transcription process using the client API. Specify the model used for transcription as a Whisper1. Pass the opened audio file to the transcription method. Start creating a chat completion for summarizing the transcript. Specify the chat model to be a GPT for 4.1 mini for summarization. Provide messages to the chat model, system role specifies the task. Provide messages to the chat model. User role includes the transcript text. Print the resulting summary obtained from the chat model. Running the cell now. This output shows a file not found error, indicating the program couldn't locate the audio file at the given path. In this troubleshooting lesson, it reminds you to double-check that your file path is correct and the file actually exists before running the transcription and summarization code. Ensuring the file path is accurate is key to successfully loading your own audio for processing. This is a comment describing the challenge to get keyword ideas using chat completions. Prompt the user to enter a topic or theme for keyword generation. Call the chat completion creation function on the client object. Specify the model to be used for generating completions. Provide the messages list containing system and user messages. System message telling the AI to produce a list of keywords. User message containing the topic input from the user. Close the chat completions create call. Print the keywords generated by the AI from the response. Running the cell now. This output shows a list of keyword ideas generated for the entered topic, demonstrating the model's ability to understand and expand on the theme. Notice the clear, relevant keywords that capture different aspects of climate change, matching the intent of the code to create useful, thematically connected keywords. This confirms the Chat Completion API is correctly processing input prompts and returning structured, contextual suggestions. Recap. You learned how to set up and use the OpenAI API in Python. We covered chat completions, speech-to-text, and embeddings. You tried mini-projects and challenge exercises. Now you are ready to build your own smart apps. Running the cell now. Thanks and next steps. Congratulations! Now you have the basics of the OpenAI API in Python. Try using these features in your homework or hobby projects. Check the OpenAI docs for advanced examples. Like and subscribe for more beginner AI lessons. Running the cell now.